Something appeared in the early universe that looked almost harmless. A tiny red point of light. No obvious shape, no dramatic explosion, no giant galaxy surrounding it. Just a compact, distant object glowing in a universe that was still incredibly young. But when astronomers looked closer with the James Webb Space Telescope, the object began to look less like a normal star and far more like something hiding a violent secret. Because this may not be a star at all. And if that interpretation is correct, it could help explain how some of the earliest supermassive black holes appeared so quickly. The mystery begins with a strange population of objects astronomers call little red dots. JWST has revealed many of them at enormous distances, meaning we are seeing them as they existed hundreds of millions of years after the Big Bang. They are remarkably compact. They appear red in infrared observations, and some are so small and intensely bright that fitting them neatly into the familiar picture of early galaxies becomes surprisingly difficult. At first, there was an obvious possibility. Maybe these were simply young galaxies. The early universe was filled with rapidly forming stars, and enormous clouds of gas were collapsing under gravity. Perhaps these tiny red objects were just unusually dense collections of stars undergoing intense formation. But then something didn't quite fit. Their light showed characteristics that could be difficult to explain with ordinary starlight alone. And one of the most intriguing possibilities began to emerge. What if something much more powerful was hiding inside? A growing black hole. Not a quiet black hole drifting through space, but one surrounded by gas falling inward at tremendous speeds. As that material spirals toward the black hole, gravitational energy can be converted into enormous amounts of radiation. The black hole itself would remain invisible, but the region around it could shine intensely. From billions of light years away, that tiny glowing region could look almost like a tiny star. There is an important distinction here. Astronomers have not established that every little red dot is a black hole. The observations are real. The objects are real, but their exact nature is still being investigated, and multiple explanations remain under consideration. That uncertainty is what makes these objects so interesting. Because if at least some of them really are rapidly feeding black holes, another problem suddenly appears. The universe may have been producing massive black holes much earlier than we expected. The first black holes should have needed time to grow, yet some black holes observed in the early universe were already enormous. So astronomers have been trying to understand how gravity could build something so massive so quickly. And the little red dots may offer a missing piece of that puzzle. They could represent an early stage in which a compact, rapidly growing black hole was surrounded by dense material, making the entire system appear deceptively small. But there was another clue. The strange red appearance wasn't the only unusual feature. When astronomers examined the detailed light from some of these objects, they found patterns that could point toward extremely energetic activity occurring in a very confined region. Suddenly, the innocent-looking red dots became something else entirely. Possible engines, possible black hole nurseries, or perhaps something we haven't fully understood yet. And the deeper JWST looked, the stranger the picture became. Because these tiny red objects weren't simply appearing in the distant universe, they were appearing everywhere astronomers looked. And that raised a question that could change the story completely. If these tiny red objects are powered by growing black holes, how did so many of them appear so early?
The answer may depend on what is actually producing the light. For decades, astronomers have understood galaxies as enormous systems of stars, gas, dust and dark matter. Black holes could sit at their centers, but the black hole itself was not expected to dominate the appearance of an entire young galaxy. The little red dots challenge that simple picture. Some observations suggest that their light may come from an extremely compact region around a rapidly feeding black hole. If so, the object isn't really a tiny galaxy at all. It is an active engine hidden inside one. And that changes the mystery. Because a black hole doesn't need to be born enormous to become enormous. It needs a supply of matter and enough time to keep feeding. Gas falling toward a black hole can form a hot accretion disk. As the material loses energy and spirals inward, the surrounding region can become extraordinarily bright. From our perspective, billions of light years away, that entire system can collapse into a single point of light, a red dot. But there is a major complication. Not every unusual spectrum means a black hole. Young stars can produce extreme radiation. Dense clouds of gas can reshape the light we see. Dust can absorb some wavelengths while allowing others through. And the early universe itself was very different from the relatively mature cosmos surrounding the Milky Way today. So astronomers cannot simply look at a red point and declare black hole. They have to examine its light in detail. That is where JWST becomes so powerful. The telescope doesn't merely take beautiful pictures. Its instruments can separate infrared light into spectra, allowing researchers to search for signatures hidden inside what otherwise looks like a featureless point. Those patterns can reveal what kinds of atoms and molecules are present and how the emitting material is moving. In some little red dots, the data have produced evidence consistent with rapidly moving gas close to a powerful central source. That makes the black hole interpretation increasingly compelling for at least some members of this mysterious population. But compelling is not the same as proven, and that distinction matters. The scientific debate is still open over exactly what these objects are, how they formed, and how much they contributed to the early universe. One possibility is that they are compact galaxies whose light is dominated by active black holes. Another is that some represent a phase of rapid black hole growth hidden behind dense material. There may even be more than one explanation. Yet the most fascinating consequence is not what the objects look like. It is what they could tell us about the first generation of massive black holes. Before JWST, astronomers already knew that surprisingly massive black holes existed at very early cosmic times. The problem was explaining their rapid growth. The little red dots may point toward an environment where black holes could feed efficiently, grow rapidly, and become powerful enough to influence their surroundings. In other words, they may be snapshots of a process that was happening when the universe was still assembling its first major structures. And that brings us back to the tiny red object. It looks small. It looks distant. It almost looks like a single star. But appearances are deceptive across cosmic distances. What seems like one point of light can actually contain a vast amount of physics. Gas collapsing under gravity, radiation escaping from extreme environments, and perhaps a black hole consuming material at the center. The strangest part is that the object doesn't need to violate the laws of physics to seem impossible. It only needs to reveal that our picture of the early universe was incomplete. The little red dots may not be proof of one revolutionary idea. They are something more valuable. A warning that the early universe was more active, more crowded, and potentially far more violent than we once imagined. And somewhere in those faint red points, JWST may be catching black holes in the act of becoming enormous. Not after they had already transformed the universe, but while they were still growing. And that is why this object shouldn't exist. Not because it breaks physics, but because it is forcing us to reconsider how quickly the universe could build its most powerful objects.